Today we're looking at the product to sum formulas and then the sum to product formulas. Your product to sum formulas are listed here. You start with a product because you have two things multiplied together on the left side. And then you could write it as a sum, two things added together on the right-hand side. And you might think, well, this is a subtraction sign, but remember, subtraction is really adding the opposite. So it's really still a sum over here. So here we have a product, and we want to write it as a sum. It's a sine of an angle, cosine of an angle. So you can look here, it's sine of an angle, cosine of an angle. So we're going to use the top formula. We'll go 1/2 sine, and then we have to add our angles, plus sine and subtract our angles. Our two angles are 4x and 3x. We add them here, we subtract them here. So we go 1/2 sine, simplify our first parentheses to 7x, simplify our second parentheses to x. You can leave your answers like this, or if you want to put that 1/2 in front of each one by distributing through, you're welcome to. Here we have the sine times a sine. Sine times a sine is here. It's 1/2 cosine of your angles, subtract your two angles, minus sine or cosine, and then add your two angles. So 1/2 cosine minus cosine, subtract your two angles here, add your two angles here. So we bring down that 1/2, we get 3x minus 1x is 2x, 3x plus 1x is our 4x. You could leave it like that, or you could distribute through that 1/2 and put the 1/2 in front of each trig function. We also have kind of the reverse process, where you start with two things added, and can write it as a product. And so here are those formulas. So here we have a sine minus a sine. So that's our second formula, sine minus a sine. So to write it as a product, we got to go 2 cosine of your angle, and then go sine of that. So we have to add our angles together first. Our angles are 5x and 3x. We add them together here. And then it says we have to subtract them here. So 5x minus our 3x goes here. So if we add these angles together, we get 8x divided by 2 is 4x. So we'll go bring that 2 down, go cosine 4x. Here we subtract our angles, we get 2x divided by 2, we get this. So we want to go ahead and find our zeros of this. Well, to find your zeros, it's easiest if things are factored or multiplied together. So we're going to take our sum and rewrite it as a product. It's a sine plus a sine. That's the top formula here. So we know we're going to have to go 2 sine. Then we have to add our two angles together, divide by 2. Our angles are 5x and x. We add that, we get 6x divided by 2 is 3x. Then we have to go cosine. And then we have to go ahead and subtract our angles. 5x minus x is 4x. Divide by 2 is 2x. Now we have a couple things multiplied together to give us 0. If you look at this, you have a sine times a cosine, and it times it by 2. So you can set all these equal to 0. We could have left that 2 out, or we could have left it like this, but it doesn't make a difference. We could divide by 2, and that sign disappears here. And then you ask yourself, when is sine equal to 0? Well, sine is your y value. That's at the very beginning, which is over on the positive x-axis at 0, and then on the far left side at pi, and 2 pi, and 3 pi, and 4 pi. So basically your angle of 3x is equal to any multiple of pi. So when you finish getting x by itself, we get this. Well, that was setting this first part equal to 0. It is possible this second part could be 0. So we can set cosine 2x equal to 0 and solve that. So then you ask yourself, when is cosine equal to 0? Well, that's top of the circle and bottom of the circle. So we'll go 2x, top of the circle, and then it's bottom of the circle, then top of the circle, then bottom of the circle, basically plus any half a revolution thereafter. Then you finish getting x by itself by dividing everything by 2 or multiplying by a half. Then as we look here, we want to go ahead and solve this. Well, it's going to be easier if we can have things multiplied together. Right now we have cosine minus cosine to begin with, so I'm going to try to rewrite those as a product. Cosine minus cosine is using this bottom formula, which says negative 2, sine, add your angles, divide by 2, sine, subtract your angles, divide by 2. So when we do that for the purple, we get this. Still bringing this down, the sine of 2x. Oh, now you have a negative after a sign. You got to think back to chapter 6, section 4. There was stuff in your notes in big, bold font. And you should remember that the sign of negative x is the opposite of the sign of positive x. So there's a negative that comes out in front, but then that negative there cancels out this negative here. Now you can see we have two terms, what's before the subtraction sign and what's after the subtraction sign. So at this point, you can look for a common factor. You'll realize, hey, we got the sine of 2x, so we can pull that out. Then you look at what's left. We'd be left with a 2 and the sine of x, and then we'd be left with just a 1. Ah, sine of two things multiplied together. The only way to get 0 as an answer is either if the first thing is 0 or if the second thing, the parentheses, is equal to 0. Here, we got to still finish getting sine by itself, so add 1, divide by 2. And then you can ask yourself, when is sine equal to a half? Well, sine's equal to a half at pi over 6 and any revolution thereafter, and at 5 pi over 6, or any revolution thereafter. Here, when is sine equal to 0? Well, that's at any multiple of pi, because that's at 0, pi, 2 pi, so on. So when we get x by itself, we would get this. We are given a restriction of looking for our answers only on a certain interval. If you were not told to find it on a certain interval, what we have right here, a pi n over 2, and pi over 6 plus 2 pi n, and 5 pi over 6 plus 2 pi n would be your answer. But because you're looking for your answer on a certain interval here, then we got to go ahead and start plugging in numbers for n. So if I go ahead and plug in n being 0, I get 0. If I plug in n being 1, I get pi over 2. If I plug in pi being 2, I would get pi. If I plug in pi being 3, I get 3 pi over 2. If I plug in pi being 4, I get 2 pi. And I'm not going to go beyond that because I see I'm going up to 2 pi but not beyond 2 pi. But because I'm going also to the negative direction, I got to start plugging in numbers that are negative, like negative 1, negative 2, and so on. Plug in negative 1. Plug in negative 2. And I get negative pi. Plug in negative 3, and I get negative 3 pi over 2. Plug in negative 4, and I get negative 2 pi. I'm not going to plug in negative 5 because that will go beyond my negative 2 pi. But I also have to do that here for this one. So I could plug in 0 for n in each one, and I get pi over 6 plus 5 pi over 6. I could try plugging in 1. Well, then it would be 2 pi plus something and 2 pi plus something, which I know is beyond 2 pi. So I'm not going to plug in 1 because it's outside of my interval. Then I could plug in, to get the negatives, n being negative 1. So it'd be pi over 6, basically minus 2 pi, and then 5 pi over 6 minus 2 pi. So I get negative 11 pi over 6 from here. I get negative 7 pi over 6 here.